Hi, myself Dr. Lakshmi Devi, Professor, Department of PCE, St. Peter's Engineering College. I'd like to give here image compression, fifth unit in digital image processing subject. So what's the basic image compression? It is the act and science of reducing the amount of data required to representing image. It's the most useful and commercially successful technology in the field of digital image processing. Innumerable number of images compressed and decompressed daily we are observing. Then what are the different techniques we are using for compressing that particular images or videos that we would like to discuss in today's topic. So lossy and lossless compressions, these are two basic techniques in the image compression. Lossless compression is preferred for archival processes and often for medical imaging, technical drawings, as well as clip arts, etc. So lossy compression methods especially used at low bit rates, introducing compression artifacts, and lossy methods are especially suitable for natural images in general, such as photographs, minor loss of fidelities wherever it is acceptable. There we can use this type of lossy methods of compression. So let us start the first differences between the lossy and lossless compression in today's session. Lossy compression and lossless compression are the two terms widely categorized under data compression methods. The major difference between lossy compression and lossless compression is that lossy compression produces a close match of the data after decompression, whereas lossless creates exact original data. The name itself defines lossless reduces a less amount of data compared to the lossy compressions. Data compression is a method of lessening the size of the data without significant loss of information. In both the cases, there is no significant amount of loss of information, but as compared to the lossless, lossy compression have more redundancy. So basic differences as a tabular column here we can observe the differences between the lossy and the lossless compressions. See, first basic difference, lossy compression is a family of data encoding method that utilizes imprecise estimates to represent the content. Lossless compression is a group of data compression algorithms that permits the original data to be accurately rebuilt from the compressed data. Then what are the different algorithms in general you can prefer for these two different types of compressions? Transform coding, discrete cosine transform and discrete wavelet transform, then fractal compressions. These are the just different algorithms we can use for lossy compression. In case of lossless compression, run length coding, LZW arithmetic encoding, Huffman coding, Shannon, Fana coding, like these are the different algorithms used for lossless compression. Exactly in practical applications, these are all useful based on different applications. Where we are exactly using this lossy means for images compression point of view, as well as for audio signals as well as video signals point of view, we can use this lossy compression. In case of lossless, text or program, images and sounds. Both the cases images here you mentioned, but which type of images we can prefer for the lossy, which type of images we can prefer for the lossless, it depends on the type of images used in that particular area of application. We are going to prefer either lossy or lossless compressions. Then what are the basic applications of Lossy compression means? JPEG, GI, MP3, MP4. These are the different application standards we are using for the Lossy compression. And similarly, lossless compression also having this bitmap, PNG, WAV, ALAC, etc. These are the different formats of applications used for lossless compressions. Data holding capacity of the channel. In case of lossy compression, because we are going to minimize more amount of information, that's the reason data holding capacity of the channel in case of lossy compression appears to be more. But in lossless compression, less data holding capacity is there as compared to lossy compression methods. So lossy compression produces a close match of the data after decompression. Lossless creates exact original data. These two sentences defines exactly lossy compression, what type of results we can extract, and in lossless compression, what type of results we can extract. In case of lossy compression, close match of data after decompression, there is a possibility to extract, and in lossless, it creates exact original data. Lossy compression methods eliminate some amount of data that is not noticeable. This technique does not allow a file to restore in its original form but significantly reduces the size. The lossy compression technique is beneficial if the quality of the data is not your priority. Whenever we are giving priority to the quality, definitely lossy compression may not be preferable in that particular area of applications. If it slightly degrades the quality of the file or data, but is convenient when one wants to send or to store the data. Whenever we are giving importance to send the data and store the data with the less memory space usage, with the less bandwidth for the transmission, then we can prefer this lossy compression method for reducing the redundant data appears in images. This type of data compression is used for organic data like audio signals and images. Then, what are the different techniques we are using for lossy compression? Transform coding technique. In this method, transforms the pixels which are correlated in a representation into disassociated pixels. Method of transforming pixels which are correlated in a representation into disassociated pixels. With the different transforms, we can use this particular coding. Whenever we can use the transforms, more frequently used transform is the discrete cosine transform, discrete wavelet transform, like that. Whenever we are using these transforms, based on the transformations presence in that transforms, we are going to have the representation of coding techniques. Accordingly, we can evaluate the compressed information at the encoder section. The same inverse transform should be applicable at the decoder section in order to retrieve the original or compressed image at the output of the decoder section. The new size is usually lesser than the original size and reduces the redundancy of the representation. Definitely, in lossy compression techniques, redundancy is more. That's the reason output image, it's a very less space it occupies compared to the original images. Then discrete cosine transform and discrete wavelet transform plays a major role on transform coding techniques. This is DCT is the most vastly used image compression technique. JPEG processes centers around DCT. DCT process divides the image into distinct parts of frequencies. In general, we are going to divide an image into 4 equal parts. That 4 equal parts should be named as lower low level, low high level, high low level, high level. In this way, we can divide the original image and then we'll go for quantization process. In the quantization step, where compression basically occurs, least important frequencies are rejected. Least important frequencies are rejected that plays a major role in the quantization process through with this particular transform coding techniques. And the critical frequencies are retained so that the image can be obtained in the decompression process. The reconstructed image could contain some distortion, definitely, because we lost some redundant data. The two psychovisual redundant data should be removed with this particular transform coding techniques. That's the reason the reconstructed image, that is decompressed image, definitely it gets degraded the quality as compared to the original image. Then discrete wavelet transform, it provides a location of time and frequencies simultaneously and can be utilized in decomposing a signal into component wavelets. The component wavelets already we discussed in the second unit of discrete wavelet transform. With that, the process of transform coding taking place with a discrete wavelet transform. Lossy compression, lossy compression techniques. Discrete wavelet advantages and disadvantages if we discuss here. The biggest benefit of lossy compression is that it significantly reduces the size of the image file. The biggest con is that this is achieved with a loss of quality. Most compression tools available will let you choose the degree of compression that will be used on your images. Based on interest of the user, we are going to choose the compression ratio. Accordingly, the compression is taking place in this particular lossy compressions. Coming to the lossless compression. The lossless compression method is capable of reconstructing the original form of the data. The quality of the data is not compromised in lossless compression. This technique allows a file to restore its original form. This lossless compression can be applied to any file formats, can improve the performance of the compression ratio. In this lossless compression, the maximum compression ratio lies in between 2 to 10. That's the reason there is no any compromisation regarding its quality of an output image. What are the different techniques we are using for lossless compression means run length coding RLE. This technique reduces the frequency of repeating symbols in a string by using a special marker at the beginning of the symbol. Based on extending each and every significant image or significant line or significant data, we are going to consider this type of run length coding based on the type of data or type of image which is used for the compression. This technique actually reduces the frequency of repeating symbols in a string by using a special marker. With this, the encoding coding techniques incorporated in this particular run length with for the lossless compression. Coming to the second technique, Lempel-Jive-Welch. This technique also works similar to run length coding technique only and searches for the repeating strings or words and stores them in variables. It then uses a pointer at the place of the string and the pointer points the variable in which string is stored. Then the third one for lossless compression technique is Huffman coding. This technique handles data compression of ASCII characters. It constructs a full binary tree for various symbols after computing the probability of each symbol and place it in decimal.